This project is the taper coupling for the coupling assembly. And we want to open up your project sheets, and I'm going to go down to our taper coupling on the bookmark, and you'll see that there's a complete set of drawings here. There is not any step-by-step information. So we're going to go over a sample of this. And I already opened up the part and I put it into isometric. And one of the things I want to do is take a look at the history, the file history, and you'll see that originally this was in 1996 again. So it's an old part created with, I would say, Pro Engineer 15 or 16, old version. So you're going to see over here in the model tree some different aspects than you'll see in Creo. And but what I've kept this part exactly like it was modeled in the beginning to show you some of the do's and don'ts. So I think what we'll do is we'll go to the model player and start from the very beginning with our standard datum features, and then our first revolved feature. And I think this is a pretty good way to start it. And it looks like they put a cut in there. And they put a chamfer on the bottom, so they're working on the solid portion. And then all of a sudden they do everything at once, and this is what you want to avoid. We'll go in and look at this later. They did the taper cut, everything all in one section. Through a couple of other things. I think in general you got some rounds and some other items that they added to it. So there isn't too much as far as complicated geometry after this. You can see they put the cut down the middle here for the key seat. And then they did a revolved cut here. And then they patterned it. So I'm going to push it all the way to the very end here. I'm going to take a look at each feature individually. So again, the very first one is very simple. They just did a revolved protrusion. And they've got their diameter dimensions in there, and fairly clean, simple. I think what I'll do is I'll back this up. Go to the cut next. Did a little cut on the bottom. And I'll go into the sketch view. So I just did a simple relief cut. They put a chamfer. Another cut. Let's see where this one is. Okay, this is the one we want to take a look at. It's a closed section, and let's turn on hidden line. Now it should have been a closed section. Maybe it is not a closed section. Should be shaded. I'm not seeing a shaded. Let's go into the section. There's our shading. And you can see they've done an awful lot at one time. It's a very complicated section, especially up in here. So I'm going to come back out. Let's investigate this a little bit. Let's really take a good look at it. So I'm going to come down. Let's see how far I want to go. Okay, I want to go down to the counter. The keyway. You'll notice here that they didn't make their keyway go all the way through to the counter bore. So this is a problem. We'll deal with that when we get to the key seat. This cut It's far too complicated. Should divide this into pieces. And I'll go with no hidden line. And maybe we'll shut off all our datum features just so that we can see it a little bit cleaner. So basically the problem here is you should have just done the tapered cut with the information on the top for the rounds. And it should have pierced all the way through. That way, no matter what happens to the ECOs or changes for the design on this counter bore on the bottom, this could have been put in separately. The taper should go all the way through the whole part. So let's delete this. It's referenced by a bunch of other stuff, so. All right, so let's start off with, we do have our references. There is a reference to the very bottom. There's an extra reference here. We can delete that. We don't really need that as a reference. We need the very bottom and the very top, and we need the axes here too, or the datum plane. We'll use the datum plane. And we'll put an axis of revolution in, so that's a different command that was not available back when this was originally created. We had to put the axes in as a center line and then identify it as the axis of revolution. So we want to go all the way to the very bottom here. So what we're going to do is we'll start off with our line chain. And I think I'll start off at the origin down here. I'll come over and I'm going to go up near the top. But I'm going to stop. Here's the top. I'm going to stop here. Now I'm going to zoom in, and right mouse button, I'm going to use the 3-point tangent, hook it to the line, and I'm going to aim at the top, not go all the way to it. Kind of a steep angle here. And then we're going to use a fillet. We're going to click on the curve and the top, and then we've got to zoom in. Got our tangency point. Got a lot of diameters in here. There are a few things we're going to have to add, like a dimension. The book does want this. The project pages want these 2 radiuses. And there's also a diameter dimension, but we'll worry about that later because we're going to really want the diameter to go to this tangency point. All right, so let's finish this up. We want to make a closed section, like so. And we do want a dimension for our radius. So if we look at our dimensions here, let's go to, I think I have a section. We'll go down to the section. I guess this is the best one we're going to get in here. For your taper, you can see the dimensioning scheme that's wanted. So you're going to have to do that. Right now we can leave it. The main thing that we have is these appropriate dimensioning scheme as far as our fillets goes. Right? And again, you can add your dimension. I think which one they want is the one to the center point down here. And they want a diameter dimension. Let's see if we can get that one in there. So center line, point, center line, middle mouse button. And that's supposed to be, I think, 50 or something like that. Yeah, 50. So no matter what happens, the main thing also with this is make sure this angle is correct. If it's not the same as for the taper on the shaft, then these will not go together with a coincident constraint. And that's very important. So this is 2.86. And I won't bother to change all the other dimensions. The main thing to notice here is then when we're complete, this goes all the way through. So then you put your counterbore in here and you finish off the main part of the construction for the coupling. You put your holes in, and that will look at that, and also we'll look at the key seat. But the main thing here is that you're dividing the information that cuts up so that one of them has just a cut, angle, taper, and a couple of rounds. Goes all the way through the part. So no matter what happens with the counterbore down here, it's not going to influence this first major cut of the feature for the feature. And we'll back that one out all the way, hopefully. Yeah. All right. So once you've done that, then you're going to put in this counterbore portion on the bottom. And again, when you do this, this will be the second cut. And it'll be easy to divide the information up. You're just going to have this come over straight this way, and it's just going to be the bottom portion here that you put in. Much easier to sketch and accomplish that. You're not going to worry about the taper. So we'll go back out. Now, we did talk about the fact that this is incorrect. And we can see that it's forming a little lip down here. So let's edit the definition of that and see how they did it, first of all. So they did a lot of construction here. First of all, they had to put a datum plane in on an angle in order for this to work. Datum plane is perpendicular to the cylinder here. Then they put a cut through. Kind of strange. But what they forgot to do is to go through all. They only went up to this surface, and by doing that, they got that little lip in there. In other words, the key seat never went all the way through. I mean, at the very least, they could go to the very bottom, and now the key seat goes all the way through. At the very least, that's what they could do. But let's do this a different way. There is a better way than this. I'll turn on my datum plane, maybe the axes too. And I'm going to sketch on DTM3. And we're going to, I want to come out of here for a second. I want to make sure I pick my remove material. And I'm going to sketch on DTM3, like I said. All right, so here, instead of looking from the end, we're going to look from the side. And our most important thing here is the reference of the angle of the taper. We need one on the top. We've got one on the bottom also. So we simply need to do one line here. And make sure it's parallel. You can adjust this dimension as per the book. And let's go back into our shading. And be careful here. You obviously want to know which way you're going to go with it. How about if we're cutting this way? Also, we want it to be what? Symmetric. A little big. I'll leave it kind of large so we can see it. So one line. No matter what happens to the part, as long as the taper is there, the keyway will be there, key seat. So the other one is more complicated. This is just one line, very easy to do. It's controlled by the taper angle, and you're done. All right, so the next one we want to look at is the cut here. And we have a hole. Well, we can go through that one. Let's go through the slot. Now, a slot is nothing more than a revolved cut. So they did this a little bit different. Edit the definition of it. And this is an old style command. When you do it, you're going to be in the dashboard. So that's why it looks like this. And we'll go into the sketch view. Now, it's kind of interesting what they did. They just did a revolved cut. The only thing they forgot to do here is they forgot to use the diameter dimension. So, dimension, center line, line, not center line, center line again, middle mouse button. Nope, I didn't get it. Let's try it again. So, we'll try the line first. Make sure we're picking up the line. Line. Oh, okay, so the person didn't put a center line in there. So it looks like a center line. Let's see what it says. Nope, just a line down the middle. So let's put a center line, axis of revolution down there. Okay, and then dimension, center line, line, center line, middle mouse button, and get rid of the half dimension. So at least we have a bolt circle diameter. Now the other thing they did when they created this one, they used a revolved cut, of course, called a slot. Yours would be a revolved protrusion, removed material. But they referenced the top so they could get the counterbore dimension in there. That's a good thing to do. Got the counterbore diameter here. Counterbore diameter, I mean the hole diameter in the bottom. I don't know what this is for. Kind of an odd dimension to have there. Let's change it. Oh. Okay. So they've got something screwy over here. Let's put in a constraint. There we go. So we made that vertical and got rid of that extra dimension. So this is one way to do it. Oop. It swept it around with the pattern. So I was messing around with that particular feature. So there's another way to do this, obviously, and that's just to put in a simple hole. So what we'll do to put the hole in, instead of using a revolved cut, let's turn everything on so that we can see all of our features. I had turned them off. And I think I'll go to the standard orientation. And I'm going to put a new hole in instead of using the revolved cut. And the type of hole is going to be a standard hole, no thread, clearance hole. It's going to be through. It's going to be a counter bore. And I'm going to place it on the same flange area here. And in the offset references, I want to pick the center line. But actually, I should have done this first. I want to make this a diameter. And then hold down my control key and pick on one of the datum planes so I get an angle. I'll leave it where it is. Let's look at the shape. So let's go and make this, I think it's 25. And I think the hole is, well, I'm just going to guess, actually. I'm not going to go exactly like the book, just to show you that it can be done. Now, I'm a little bit far out on this one, obviously, so I would have to decrease the counterbore there. And let's change the size a little bit. No, it's actually bigger than that, isn't it? So that looks okay. All right, just to get an idea of what it would look like if we did it this method. So there's my hole. I know it's not an exact correct spot, but what we want to do is take it and move it so that it comes above the group here and it pierces the fillet. So then from there, of course, we can simply pattern it. You have your dimensional pattern, or you have here, in this case, would be an axial pattern. Axis would be here. We would want a total of 3 at 120. Let's see if that preview is okay. And there it goes. And again, it's not in the right spot, but it is a quick way of doing it compared to using the cut method. This ends the taper coupling project.